Okay, we're back with the first example involving integration by parts. You can see up here over my shoulder, our charge is to find the antiderivative of x cosine x dx. Okay, and we're going to use this concept right here. The antiderivative of u dv is equal to u times v minus the antiderivative of v du. Remember, we derived this equation from the product rule. Okay, so this antiderivative of u dv has to match up with what we see over here, x times cosine x dx. In other words, we have to give some of these values to dv and the other value to u. So the question is, what do we pick as our u? Okay, and you can see this nice mnemonic right up here, Lipit. Lipit is a not foolproof, but as far as the exam is concerned, good enough mnemonic to know the order in which you want to pick your functions to be u. All right, so this is for picking u, or choosing u. Okay. The L stands for logarithmics functions. I stands for inverse trig. All right, so if you have a log, that's going to be your first choice for u. If you don't have a log, then you go to your second choice, which is inverse trig. We don't have either of those here, so we're going to have to get further down into the mnemonic. The P stands for polynomial. The E stands for exponentials. And then the T stands for your trig, not your inverse trig, but your regular trig. So you can see in this problem right here, we have x. X is considered a polynomial, and then we have cosine x. So we have the P and we have the T. In Lipit, the P comes first. So the polynomial part of this will be our u. Okay, so basically what we're doing is we're matching up right here, u dv. So we know that u will be equal to the polynomial part. That's x. Okay, and the dv will be the differential term, which will be the other part, which is cosine x dx. Okay, so we've made that little identification. Now you want to go, why are we making this identification? Well, let's take a look at what we know that this will be equal to. We're going to have u times v, and then the antiderivative of v times du. So obviously we need v in order to get something over onto the right side of this equation. We don't have v, we have dv. But thankfully, we can find v. We can find v by doing the antiderivative of dv. What is the antiderivative of cosine x dx? Exactly, it's sine x. Cosine's derivative is sine. So v is going to be sine x. And now, isn't it true that v's derivative, which is right here, would be cosine x? Absolutely. So we have v now. Okay. We also need du. Well, here's u. Let's get the derivative of u. What's the derivative of x? Hardest question you're going to answer all day. Yeah, it's going to be 1 dx. I'm not even going to bother to write the 1. Okay, so what we've done is we've chosen u and dv, and then we've used u to get du, and we've used dv to get v. Now that we've done that, and again, let me just write up here, here's my u, and then this right here was my dv, u dv. Now I know that what I've done up here will be equal to this difference right here. So let's continue onward. I know that this antiderivative up here is equal to, I see u times v. U is x, v is sine x. So I have x sine x. All right, and again, I'm just kind of writing in orange right above it. So this is my u, and that's my v, and it matches up right there. Okay? And then I need to subtract, and now I have the antiderivative of v times du. Well, v is sine x, du is dx. Okay, so you're saying, well, wait a minute, Sylvain, I've created an equation, a difference here, but it has another antiderivative. So I've gone from one antiderivative to another antiderivative, and that's true, but let's study these antiderivatives real quickly. This was one which we had no easy way to get the antiderivative. However, this is a much, much easier antiderivative to find. Okay, and that's the idea behind integration by parts. We're going to create another antiderivative, but the one that we create will be easier than the first one. And therefore, we can now do this. We can work with this side of the equation, and ultimately it's still equal to what's up there. So let's work this right here. there's no change to the first part. We still have x sine x minus, and now we have to take the antiderivative of sine. All right, so from last year, what's the antiderivative of the sine of x? Yeah, the antiderivative of sine is negative cosine. All right, so we have negative cosine x. What goes at the very end? Exactly, your plus c, don't forget that. Okay, there's my arbitrary constant. Okay, and so what do we have here? We have x sine x, and with a little simplification, plus cosine x plus c. That's the function, that's the antiderivative of this right here. Okay, and hey, you can always check your answers of anti-deriving by just deriving your answer. So if we do a very quick check here, all right, because again, let me circle this off. This is our answer. This is the antiderivative of x cosine x. All right, let's just for right now, let's just call this f. Okay, this is f of x. Okay, so if I want f prime of x, if I were to derive this, here we go. I have x times sine x. I have to take the derivative. That's a product rule, correct? All right, so derivative of the first, x's derivative is 1, then we keep the second, so we keep sine. So we have 1 times sine x plus. Now we keep the x, and we derive sine. Derivative of sine, cosine, exactly. So we got cosine x right there. Plus, now we take the derivative of cosine. What's the derivative of cosine? Negative sine, the opposite of sine. So we have minus sine x, and then we take the derivative of a number. We all know that that's 0. So this is our derivative. Sine x plus x cosine x minus sine x. You can see right now, I know you're looking at this and you see how it pops out. The signs eliminate each other, and what are we left with? X cosine x. So when you're doing this integration by parts, what you're doing is you're coming up with a multi-term solution. But if you were to derive that multi-term solution, what ends up happening is stuff from the first part of the derivative cancels out stuff from the second part of the derivative, and when all is said and done, only the initial integrand is left over. Okay, so that's integration by parts. It's known as a first iteration, or a single iteration of integration by parts. In other words, we only have to do this once to get our answer. Next video, you're going to see how we have to do a second iteration to get our solution.